write an explicit formula for the sequence. Well, this looks pretty wild. We got 10, 6 is the first term, and then this is my second term, third term, fourth term, fifth term, sixth term. Let me circle the first term. So those terms and etc. There's some kind of pattern there. We're like a scientist looking for a pattern. What formula is making that happen? In other words, what formula could I plug n equals 1 into and I would get 10/6? And could I plug n equals 2 into and get this? And plug n equals 3 into and get all that? And plug n equals 4 into and get all that? And plug in n equals 5 and get all that? And plug n equals 6 and get all that? How's that going to work? That just looks wild. Is there some formula that'll make all that happen? Well, what I suggest is to don't worry about the first one right now. Just pretend he's not in there. He's kind of confusing. Let's just start with the second one. What's the connection? Look at these numbers. Look at 12, 13, 14, 15, 16. Do you see what's going on there? How does 2 compare to 12? How much bigger? 10 bigger. How does 3 compare to 13? 10 bigger. 4 to 14. 5 to see it's always 10 more. So that part is just going to be n plus 10. That'll produce this part. Right? When you plug in 2, if I plug in 2 there, I'll get 12. If I plug in 3 there to the formula n plus 10, boom, I'll get 13. But that's not all. Let me scoot that over so there's more room here. Okay, now, what about this pi to the first, pi to the second, pi to the third, pi to the fourth, etc.? Well, what's the connection? You always want to say, what's the connection between this and this? It's 3 and 2. It's how much higher or lower? 1 lower. That's just 1 lower than n, isn't it? So that's going to be minus pi to the n minus 1. Minus pi to the n minus 1. See how that works? If you plug in 2 there, which you'll get pi to the 1, which is right. If you plug in a 3 there, you get pi to the second, which is what you're supposed to have underneath 3. See how that's working? Now for the bottom, the denominator. So how do I get this 10? What's the connection between 2 and 10, and 3 and 15, and 4 and 20. See, I just keep trying to look for a connection between the n value and the numbers that appear in these terms. What's the connection? You see it? How does 2 become 10, and 3 become 15, and 4 become 20, etc.? It's multiplied by 5. It's 5 times n. 5 times n, right? If you plug in 2 there, 5 times 2 is 10. If you plug in 3 there, 5 times 3 is 15. Etc. It'll work. Plus, now there's another pi thing. Pi, and then the bottom is the same as the top. So that's going to be n minus 1. Just like the top was, right? The bottom numbers always match the top. So, now there's my formula. That works for n equals 2 and 3. But does that formula work for what I didn't? So that'll work for this term, this term, this term. You can check any of those. It'll work beautifully. But let's go back now to the first term. Will that make 10 over 6? If I plug n equals 1 into this, so I'm saying the formula. What I'm saying is the formula is, let me write it out here, is n plus 10 minus pi to the n minus 1 power all over, do that a little better, all over 5n plus pi to the n minus 1. So if I plug in 1 there, there, and there, what will I get? 1 plus 10 minus pi to the 1 minus 1 over 5 times 1 plus pi to the 1 minus 1. What does that equal? Well, that's 11 minus pi to the 0. What's that? Over, well, 5 times 1 is 5 plus pi to the 0. Okay, that's kind of weird. Now, what is any number to the 0 power? That's 1. Remember that? Anything. Pi, 10 billion to the 0 power is 1. So this becomes 11 minus 1 over 5 minus 1. In other words, 12 over 4. Oh, that wasn't very good math, was it? Let me try that again. How about 10 over 4 and... Oh, wait, the bottom, look what I did. The bottom's supposed to be plus, isn't it? I'm having a lot of trouble adding and subtracting here at the end of this problem. 10 over 6. There we go. Subtracted on the top, added on the bottom. 10 over 6. And sure enough, look at that. Beautiful. First term. Once I add and subtract, right, it's working. So this indeed, so I'm just proving, verifying that indeed our answer, the formula, is n plus 10 minus pi to the n minus 1 over 5n plus pi to the n minus 1. There it is. That formula works, doesn't it? It even worked when we plugged in n equals 1. It made 10/6. And it works for n equals 2, 3, 4, etc. That's the formula that produces all those terms as we checked. It works. So there we go.